Alright, Chapter 16, Mastering Solidworks, working with assembly sketches and layouts. When working on parts in our assemblies, design work will often begin with a 2D sketch of the previous chapter to assemble a sketch for the derived patterns you can file with 3D or data created with this phase of laying out the design as a sketch, and it's only before you start making the actual 3D parts. You can single sketch, multiple sketch with either visual guide with the functional framework for the model. Visual guide is called the layout. Two-dimensional sketches are easy to produce, easy to use. The first step in the design and modeling work. SolidWorks provides both formal and informal techniques for achieving sort of effect. Topic layout sketches involve the other topics covered in context model mastering model techniques, which covered in more detail later in this book. The topics of an introduction and here to conceptual level to prepare with the detailed information later in context modeling involve the creation of relations between the parts in assembly, such as one part that drive the feature for the another part. Layout concepts apply with the context modeling because you can assembly level sketch and drive geometry with individual parts. In this chapter, you will learn to understand layout techniques and apply special treatment within the assembly. Alright, looks like an assembled piece in blue and then some symmetry line with a green and it's mirrored. Informal technique is called the assembly layout sketch. Exists since the early versions of the SolidWorks technique has included the SolidWorks official training material for many years. Simply allow the assemble level sketch. You can do only one simple things with the sketch: build up parts and on it and use drive component patterns, mate parts to it, use it and cut up in single parts for the multiple pieces. You can also adapt the assembly layout sketches technique for use a single point reference when you need to change the multiple features within a single highly complex part. Formal assembly feature called the layout. Layout is assembly level 3D sketch display with specific icons, some of the special properties. Although the formal feature and informal technique have similar names, they have different functions. In this book, the layout is used as a lowercase l to refer to the informal assembly based on the sketch layout method. Formal assembly method based on 3D sketch with special properties is referred to with a capital L layout. Layout icon in SolidWorks may also accompany formal feature. For the lowercase l is 2D, the capital L is 3D. Using assembly layout sketch. In SolidWorks, layout sketches are greatly simulate the mechanism to locate the major components of the assembly. Figure 16 will show the three examples of assemblies created within the assistance of the assembly layout sketch. So here's a pair of pliers, Tonka toy, and a grab hook. Bicycles example is throughout this book with the layout sketch instrumental with establishing geometry of the frame and the wheels and four of the most common components of the bicycle are purchased off-shelf items that may come in different size of the bike, not custom created for the individual bike. The only part of the generally custom part built for a particular size or frame and possibility the forks. Therefore, the design of the frame you may lay out with all the data that you are given with the individual components such as wheel stems, crankset, and seat. When you put everything together, additional piece of the information determine the frame geometry before the detailed design of the frame can be started. You need to know the following sizes of the wheels. Wheelbase distance between the wheel centers, length of the pedal form, the necessary distance between the bottom of the pedal and the ground, the head angle, the effect of the pivot angle, the front fork, the distance between the center of the crank and the center of the rear wheel. The workflow of this assembly layout sketches is always as follows. One a new assembly, create sketch for the sharing plane, create new reference planes that you cannot use the sketch pictures and assembly sketches. Mating existing parts of the sketch and reference geometry bottom-up method. Previously mentioned assembly level sketch in Chapter 15. Pattern and mirroring components of the way you create chain patterns where assembly layout sketches use a slightly different way. Alternatively, you can build in pieces in place where using layout sketches and reference of the top-down in-context method. First, you start with the wheels. An example, you want to design the urban utility bike with a base on the mountain bike components with a dual suspension, even the narrow tires within the means of 26-inch wheels. You need a certain amount of the ground clearance of the pedals to rotate, and with the needed clearance between the rider's toe to the backside of the front wheel. You will have the design frame of the pit of the rider, who is about 5 foot 8 inches tall. Size information is important because the distance between the wheel center of the wheelbase creates a certain characteristics of the rider's different height. A longer wheelbase generally means a more stable, comfortable ride, but the bike is less maneuverable and heavier. In this case, based on the research, you want a wheelbase of about 41 inches. Those specifications allow you to create a sketch shown in Figure 16.2. Sketching the bicycle layout sketch. Next set of information you put in the sketch that has to do with the height of the top of the bar, but it's important to stand over the bike with your feet on the ground, the clearance between the frame and the front of the wheel with the travel of the front suspension fork. This establishes most of what you need to know about the design frame, but you still have to work out the rear suspension arm with the following information layout sketches look like Figure 16.3. additional information layout sketches. With this data, you have all critical point, location, design, actual frame. First step is creating the frame and the place of the reference geometry. Sketch plane for which to make the sketch of individual tubes of frame. The frame will be a carbon fiber monoco, but it will still rely on tubular geometry with smooth blends between the tubes to reduce stress with the concentration. Layout of the planes or initial tubes are shown in figure 16.4. Alright, so now we're building the tubes of the frame. When all the tubes are created in place, assembly of the layout sketch over the top of the assembly feature manager looks like figure 16.5. Examining feature built with the assembly layout sketch. Alright, the arrow symbol will indicate that there's external reference. The part of the assembly sketch for the external reference are covered in more detail in Chapter 21, Editing, Evaluating, Troubleshooting, Assembly. The assembly layout sketch technique for the external reference of the made every time the line relationship is made with the part of the assembly sketch. Many users prefer to avoid external references mainly because of the file management issue that's caused the difficulty in repairing them when broken and rebuilding speed performance issues. However, the reference assembly sketch is more stable than the reference between the two parts in the assembly. When using assembly layout sketch for the in-context part building, simply part position of the main advantage of the offense for the give of the single driven sketch for the enables you with the change size, shape of the position of the parts. You can main layout with the sketches you want. You can make them over the different sketch planes. It enables you to control the parts in all direction. Caution, when you use layout sketches, you may assume the relationship is created such that the sketch driven with everything else. However, nothing prevents you from using other things. Assembly drive sketch, you would avoid the type of conflict called the circular reference. It can create sketches that change every rebuild, but can seriously impact rebuild times when using type of the in-context relation. Be careful to establish one or more driven entities, which are not in turn driven in other entities. To take this step further, avoid daisy changing, which A drives B, B drives C, and so on. A better practice for the A drives both to B and C directly, saves on rebuild times and troubleshooting. On drawback, the technique to give the dynamic assembly motion, one to create the part of the contact with the assembly to create the relation between sketches. Features assembly sketches can move the parts of just dragging them within the cursor of the two move parts. You must move the sketch and rebuild. The part does not move until the sketch is updated. You need to combine layout functionality with the dynamic assembly motion. You can add more instances of the context parts made with the traditional way. However, the use of the method is very carefully about the instances. You make your edits to the best because of the in-context relations are driven the original instances. I suggest defining initial component with the envelope using only copies for the movement. Drawing a bill of material shows a little something there. Drawing assembly level sketch, you cannot use the sketch picture inside of the sketch. Sketch pictures contain important reference information for the modeling of the model. The lack of capability is certain noticeable. You can put your sketch in picture and part in every virtual component. Alright, using master model. Master model techniques is covered in chapter 33. Employing master model techniques is mentioned here because of the work's alternatively method of the layout. Idea of the term master model can mean a couple of different things. It could be a single part where the multiple bodies are created later in a split with the multiple parts. Also, sometimes used after the name and insert with a single part with a sketch of the reference geometry into one or more other parts of the single reference without creating the reference in assembly. This still creates the external reference that creates only the single external reference instead of the possibility doesn't update with an inserted part can be locked, and performance problems with the techniques are less serious. As also, file management fails. Solidworks cannot find with the inserted part. You can still keep working. The Solidworks keeps enough data in the child part that it does not matter constantly access the parent part. Master model techniques seem to have more advantage than fewer disadvantage of the methods of using assembly. Dynamic assembly motion probably does not exist in a master model arrangement, nor does it lack sketch picture functionality. Example of the kind of work is shown in figure derailleur assembly in figure 16.6. This is actually the derailleur to the bicycle. I have no clue what it was drawing. Part shown on the left of the master model note that contains sketch and plane with the data. Image right shows the superimpose of the master model part. Using a layout feature to do some quick, quirky behavior layout feature is generally employed by the user. Most people that have been using the layout technique described earlier in the chapter have the switch of the method, even though they replace the older method of the Solidworks on assembly training manuals. The layout feature in 3D sketch is given a special treatment within an assembly. It works with the best for the sketch block for the special properties layout feature for the compare of the 2D assembly sketch. Usually the 3D sketch works best for the actively sketching on the plane, works best for the sketching making on the part that is made with the sketch block, is enabled to extrude the first feature of the part directly with the sketch block, and enables you to sketch relations between between blocks to turn into mates, permits unlimited dynamic assembly motion parts, move the motion blocks and layout. To initiate layout, click the layout button, layout assembly of the command manager, activate the insert menu from the insert menu area after you lay out the SolidWorks button, even in the 3D sketch in front, X, Y, and plane activated so that it displays a small grid. For now, you should just treat a 3D sketch as much like a 2D sketch as possible, but the main difference is you can double click with a different plane and start with sketching on the new plane. You can always see that the small grid of the plane is active. You can find that the 3D sketch have some limitations when you're working with layouts. For example, if the lack capacity for the sketch pad and sketch pictures. Using a layout workflow with the function of the software, any of the type you're trying to give better results, we can use them in software the way it is intended. Generally, developers have the workflow in mind when they design the function itself with a certain phase. Working the software is usually easier than working against the software. Here's a general workflow for using layout feature. Open a new or existing assembly. Click layout toolbar with layout toolbar. Command manager sketch on the plane. 3D sketch for the create. The 2D sketch representing the part of the mechanism of the other assembly. Make selections. Sketch into the blocks representing individual parts. Insert multiple instances and blocks representing multiple instance parts. 6. Use sketch relation with the block put together like mating parts and assembly. 7. Test mechanism dragging sketches block function single sketch any so that you can drag them with the sketch like parts. The assembly right block, click the block from inside outside of the layout. Select the make part from block as a button over the layout toolbar. Make part from the block command uses the large small icon slightly different from the larger icon shown in the beginning with the use layout feature selection. Working with the virtual components always exist within the in-context workflow, frequently within the layout workflow. Virtual components are part of the part or sub-assemblies that are created within an assembly. You can save the virtual component externally. You can make the external save part with the virtual component with advantage. Virtual components are that you don't have to worry about the saving out additional file with the assembly will never lose track of the virtual components. Some of the SolidWorks uses virtual components represent non-geometrical parts of the glue or paint. Anytime that you choose the insert with the component with the new part with the part, select for the template plane with the part with the part immediately into the assembly, and you can start with the working without worrying about having to save the assembly and the part. But this saves a lot of the time initially. Later you will save the assembly. SolidWorks will prompt you with the save of the parts externally, name them as well as you choose to leave the part internal with the assembly view components. Virtual components are named with the part 1 assembly 1, part 1, and assembly 1 default names can easily rename by clicking the right menu bar with selecting rename part. You cannot do this in external parts unless the option is enabled. If you make the external part virtual with the name of the assembly with a copy of the file name of the assembly 1 with the file name and the name of the external file, the name of the assembly is always included and cannot be removed. To ensure that this is if you have a sub-assembly that you have virtual components, you also have the unique file names of all the parts. Virtual components also can be accessed with their own window, which makes it easier to edit some of the purpose bill of materials, number of balloons work correctly with the virtual components, but they can have their own drawings. Best practice is to save any of the department's permanent part with an assembly with the external files. Virtual components should be limited to the temporary parts possible to non-geometrical part. Limited like bill of materials, only parts of the glue and paint. Good general rule that if you need to have the drawing of it, do not leave the virtual component. Balancing advantages and limitations. The theory of the layout feature has several advantages. You can make the parts with the blocks with layout. You can move the parts with moving the blocks and the layout. You great with the structure relation with the assembly. A single 3D sketch does not have the history of the concern that multiple 2D sketches have. The useful motion when they analyze the 2D sketch. You have the 6 sketches before and 3D components are created. Practice feature for the needs of the enhancement before it's ready. Even this real assembly 2D sketch with some of the layout sketch for the still with the better idea of the trying to have to avoid the following limitation. Formal layout feature. 3D sketch used layout have all limitations has come with the 3D sketches. Sketch relation are listed in the main folder. Gain access to edit the layout after it has been closed requires method that you don't expect from a sketch. Click out the layout button with the toolbar rather than right click on the edit with the icon with the feature manager. It requires that you use the block to access all functionality. Fully defined 3D sketch with the blocks are very unstable. The part creation for the block does not save time. You cannot paste, copy the sketch entities from 2D sketch into a layout. You cannot use sketch pictures in layout. You cannot use auto dimension polygons, ellipses for the layout. Although formal layout feature for the serious advantage of the regular layout sketches at the time, the limitations outweigh the advantage of the rest of the discussion on layouts address the general layout technique rather than formal feature. Alright, tutorial working with layout. In this tutorial, we'll use a regular assembly sketch to layout and blind, build the tooling die on Chapter 16 tutorial layout, start solid assembly from the download material. Note the layout sketch and some of the parts have been added to the already existing parts of virtual components saved inside of the assembly, so there's no reference part files. Click add new part under the insert components drop down the assembly tab. The cursor appears with the green check mark lower left hand corner of the taskbar prompts you to select the plane with the place the front plane with on the part. Sketch automatically open on the plane. Click on the front plane with the assembly feature manager. Click the corner rectangle. This gets the sketch toolbar. Create a rectangle from the two corners indicated with the Chapter 6-7. It may be helpful to switch to front view before the drawing. Alright, 16-7, creating a new plate with the context of some of the layout of the sketch. Extrude the rectangle up to the vertex condition from the direction 1 and direction 2 with a sketch of the endpoints of the plane depth layout. Sketch for the both direction. New plate matches existing plates. You will need to rotate to the front with a view to make these selections. Be careful not to click the modal face edge vertexes when creating the depth references. Make sure that all the selection and sketch needs non-solid geometry. Check. Click exit edit part icon confirmation corner with the upper right hand corner solid graphics work window. Right click with the new pattern feature menu. Select the rename part with rename it to plate 4. You can use the window standard method slowly double clicking the pressing F2 for the rename parts. Chapter 16 tutorial layout start parts with the name automatically added because the still virtual part is assigned with the part with the appearance of the tab with the new plate. Follow the procedure outlined in step 2 through 5 of the 4 remaining plates as shown in figure 16-8. Summarize the steps again. You can add the new part with create the sketch groove the block. Be careful to place the 5, 6, and 7 and 8. That there's a clearance gap between the sides of the 7 and 8 plates. Vertical plates 5 and 6. Shows all plates controlled in layout sketch 1, 2, 3, 4, 5, 6, 7, 8. Reorientate the view of the top view control 5. Make sure you can see with the pin layout sketch. Select the top face plate 1. Click the whole series tail. Whole series may be hidden with the assembly feature file with the assembly of the tool commander. Place the two sketch option points for the center of the circles as shown in figure 16-9. Make sure the 2 points are both over the same plate 5 and 6. You can cut both plate 5 and plate 5 and 6 in the same hole series features using settings shown in figure 16-9. Make sure the holes are counterbored A and side metric socket head cap screw M10 with a head clearance of a 1/10 of an inch. All other conditions should follow 16-9. Place 2 new holes on the other side. The part make the pattern parts transparent so that they can see the holes when they've been placed. Create the plane feature. Make a new plane parallel to the top plane. Assemble the coincident line indicated with the plate depth layout. Sketch figure 16-10 best displayed. Right view. Rename the new plane sprue bushing seat. Create a part with a sprue bushing seat plane. Activate the convert entity sketch tool to select the large, approximately 4-inch diameter circle. Pin layout. Sketch converting it to sketch plane. New part. Draw 1.5-inch circle from the center of the origin. Extrude the sketch 875 thousandths of an inch so that it protrudes the plate 2. Exit part mode using confirmation corner. Rename the part sprue bush and click plate 2. Edit the part from the shortcut toolbar. Open a new sketch on sprue bushing seat plane, which is part of the assembly, not a part of the part. 16-9 shows the placing of screws through multiple parts on the dies. And then show the place for the holes. Create plane assembly driven layout sketch. We've moved to the plane and then create a sketch. Select the large circle using step 13. Use the offset sketch tool with the offset of the circle of 5 thousandths of an inch. Create through all the cuts come out of the exposed side of the plate, clearing an area of the spruce bushing needed the switch of the wireframe display with accomplish this. Place chamfer outer edge of the new cut of 10 thousandths of an inch. Exit the part mode to save the assembly of the new folder. Choose the save it as, save all button, then select the save the external option shown in figure 16-11. When you start working with in-context relation file management, issues become more important. Saving the assembly in step 20, new name that will disconnect all the relations between the parts and assembly. For chapter 20, modeling in context for more in-context management information. And then we've created this saving internal virtual parts, external parts. Double click the plate layout sketch, change the 5.836 inches dimension to 6 inches, change 7.244 inches to 7 inches. Make sure the model rebuilds. Watch the individual parts update. Figure 16-12 show the dimension references. Alright, bottom line. Laying out some of the reference sketch for the more disciplined way of working to help you to avoid some of the complications with external referencing, context design. It works up to decide whether the informal 2D layout sketch is preferable to formal 3D sketch-based layout. Feature both other tools, control position and parts, even features parts within the traditional assembly modeling method, which each part is located with the mates from another part. Do not stand up well against changes of the parts themselves. The main goals of the layout methods are centralized control stability to change it. I invite you to explore some of the methods using the tools you've learned in this chapter. Master it. Use assembly layout to create 4-bar link and assemble the parts of the blocks in the layout sketch to remain. The workflow for a layout is open assembly, click layout tools, sketch the 3 bars for the different lengths, create the 3 separate sketch bars using each bar, assemble the bars, create 4-bar link mechanism. Yes, a 4-bar link can have only 3 bars, the 4-bar is ground. If you can see how this is done, use the 3 sketch, refer to the ground, download example of the chapter. This hints, test the motion, assemble link blocks, exit layout, create parts each of the box, use the sketch from the pattern, parts created, geometry for the bars, and the assembly test the motion, dynamic assembly, motion dragging parts, master it, use assembly create with the dynamic zone, example the 4-bar link layout solution, solid assembly, first rename, then save the internal virtual parts of the external and standalone parts. Master it, edit layout and previous exercises, change the length of one of the links involve the first linking layout, editing one of the blocks when you exit the block layout sketch, then solid geometry should be both update performing text and exiting layout, making sure the motion is still correct. Alright, Chapter 17, Using Assembly Tools.